Well, hello guys, welcome back to Mr. G Physics. This is Mr. G and today we're going to be making a video on another type of forces, this time frictional force. If you are new in the channel, don't forget to subscribe so you can get all the notifications and videos I post on regular basis. And the first question is, what is friction? Well, friction arises when two surfaces are in contact and move relative to each other, or they attempt to move. And here we are. Friction arises where two surfaces are in contact and moving relative to each other, or they attempt to move. They are either moving relative to each other or they attempt to move. Okay. So here we have two main scenarios. One case, the object that doesn't move, but even there is a force acting on the object. Now, why the object does not move? It doesn't move because there is friction. So there is friction in opposite direction of that attempt of motion. In this case, it's not moving, it's trying to move. So we're going to represent frictional force with small letter F. Okay, we can be 2F if you think you're going to forget. For friction, it's in the opposite direction, and that is why this object is not moving, because of friction. Now the second scenario here, the object is moving. The force that they apply on the object is bigger and the object starts moving. However, there is still friction on the surface, between the surface and the object. There is frictional force. Okay, so those are the two main scenarios here. One, when the object does not move because there is friction, and when the object moves but there is also friction. The first scenario, this frictional force is going to be called static frictional force. Static frictional force. And in this case, we represent it with Fs. Okay? Now, however, I say we represent it with Fs, but if you say Ff is fine as well. So the symbol here is not important. It could be Ff or could be Fs. You need to know that this is static frictional force. Why static? The object do not move. That is the main thing here. And this case, or this scenario, when the object is moving, there is friction, but the object is moving, we are going to call that frictional force kinetic frictional force. This is kinetic frictional force, and the symbol we're going to use is Fk. The end, still friction, so it does not really matter the symbol here. It doesn't matter. We can use either one. So those are the main two types of frictional force we are going to encounter here. One of them, when the object is not moving, however, is trying to move. Note the following. If we remove that force of 5 Newton, for example, here, this object is not trying to move, therefore there is not friction. For friction to be present, the object must be either moving or must be attempting, must be trying to move. So there is not friction in this scenario here. So here is no friction. Let's write it there. No friction, because the object is not moving or is not trying to move. Okay, so let's write the definition of frictional force before we continue here. So by definition, we can say that frictional force is the force that opposes the motion of an object and acts parallel to the surface. That is the definition that they actually wanted to write in the exam. And remember that we have two types of frictional force. We have the static and we have the kinetic. Now we can say that the static frictional force is the force that opposes the tendency of motion of a stationary object. Force that opposes the tendency of motion of a stationary object. So that is what we call static frictional force. It's very important. The symbol is Fs. Now, the frictional force, either one of them, will depend on two factors. The frictional force will depend on two factors. The first one is the surface. The surface, the material with which the surface are made. And the second one is the normal force. Okay, it has the surface, which is one of the factors, and the other one is the normal force. Now, the surface itself will have something of a constant factor. This one is going to have a constant factor called coefficient of friction. This one will have a constant factor. Every single surface is different. They will have its own coefficient of friction. Every surface will have this constant factor called coefficient of friction. And guys, because we have two, let's say, kind or types of frictional force, we're going to have two different types of coefficient of friction for every single surface. Every single surface is different. It's made of different material. Therefore, they will have this constant factor called coefficient of friction will be different for every single surface. Okay? And we are also going to have the static coefficient, and we'll have the kinetic. What I'm talking about, static coefficient of friction, kinetic coefficient of friction. This one is for the surface. This one is for the surface. Okay, coefficient of friction, and we're speaking about the surface. Each surface will have its own coefficient of friction. The symbol for coefficient of friction is going to be the Greek letter mu. This is a Greek letter mu, and that is the symbol for coefficient of friction. Okay? Now, if we're speaking about the static coefficient of friction, then will be mu s. If we're speaking about the kinetic coefficient of friction, we'll speak about mu k. Alright? This is different for every surface combination and is going to be not having unit. This is the constant that is coming, constant factor according to the different materials. So far so good. It's a little bit more tricky than before, but nothing to worry about. So now we're going to speak about the static frictional force real fast. Okay, so we're going to go here to a new page and we're going to speak about the static frictional force. Okay, so let's look at these three scenarios here. The first one, the object is not moving, the object is not trying to move, and therefore the frictional force here is zero. There is not friction, no static, no kinetic, the object is not moving, it's not trying to move or anything like that. So there's no friction. Scenario 2, the object is trying to move because there is a force acting. You can say as soon as you see a force, it means the object is trying to move. It doesn't matter how strong the force is, could be 1 Newton, could be 0,001 Newton, then the object will try to move. Very slow, but it will try. It's not moving. Okay? However, the object is not moving. Now, in this case, we're speaking about the static frictional force. Now, important, this static frictional force is going to be equal to the applied force. This one is the static frictional force. It's going to be equal to the applied force as long as the object is not moving. So this static frictional force here is going to be equal to 5 Newton, but also in opposite direction. Okay? Opposite direction. Let's write here left. Alright? Because it's the same as the applied force as the object is not moving. This one is static frictional force. Okay? And in the third scenario, now the object is not moving, just start to move. This is another story. Now we call this one here, we call this frictional force maximum static frictional force, because from here the object will start moving and it's not going to be 9. In this case we have to calculate. We need the static coefficient of friction. Remember, it's different for every surface. We spoke about that one here. And we need the normal force. In previous lesson we spoke about there is no formula for normal force, but we're going to learn how to calculate it. The fact that there is no formula for normal force does not mean that we cannot calculate it. So if we go to the static frictional force once more, you can see that it's gone for a value that is from 0 to to a maximum value. I really hope this is clear because could be a little bit confusing. We are going to learn how to do all this calculation. Important. Object is not moving, not attempting to move, there's no friction. Object is not moving, there's a force acting on the object, it means it's trying to move. Frictional force or static frictional force will be equal to the applied force. Okay, if this force moves to 6, then the frictional force will be 6. If the force move to 7, the object is not moving, static frictional force is going to be 7. But if the object start moving, is not kinetic, if the object is not moving, just started, we call this one the maximum static frictional force. We can draw a small graph to understand what we're speaking in this specific point. And if we draw a graph, it would be something like this. This will be static. Just for you to understand, on the y-axis we represent the frictional force. I didn't name because it's either one. Alright, as the object starts from 0, as the applied force, this one is applied force in the x-axis. As the applied force starting from 0, so does the frictional force is also 0. And you can see as it increases, there is going to be the same. Alright, is the same. You increase one, the other one increases, but the values are the same. But there is a point when you have here the maximum static frictional force that can actually be calculated. There is the formula. Okay, so this one is in terms of static frictional force. We're going to practice some question, and up to a point we're going to try to do some calculation. And then here that you see constant, I left for last because it's quite simple. This one is the kinetic frictional force. Okay, now in terms of the kinetic, while the object is moving, not when it starts to move, but when he's moving, you can see the frictional force decreases. Then we go to kinetic frictional force. This one is always smaller than the maximum static frictional force. Always. And we are going to write it here. The kinetic frictional force is always smaller than the maximum static frictional force. Always smaller. Alright? So this is very important to know. It's always smaller. And we can calculate the kinetic frictional force. We can calculate the kinetic frictional force by the product of kinetic coefficient of friction multiplied by the normal. Remember, eventually we're going to learn how to calculate normal. We didn't yet, we just know that does not have formula, but we're going to learn how to calculate it. It's not a problem. This very important, right? However, the kinetic frictional force is going to be constant while the object is moving. Guys, this is all only one important thing which I left for last. The maximum static frictional force is the minimum force needed for the object to start moving. Minimum force required to start moving an object, and that's it, the maximum static frictional force. This is all for friction. It is a very important topic and it could really be tricky. It could be really tricky. We didn't represent here in the bottom. This one is the maximum static frictional force. I just want to write frictional force. Guys, this is all for now. I hope it helped. If it helped, thumb up, subscribe for the channel. Next time we're going to go into more details of friction. We may do an experiment so you can see it, and we can do some questions. Thank you for watching. I'll see you next time. Mr. G here.